Good evening. It's been a while since my last video, but pretty busy with the work and everything, so haven't got a chance to make another one. But today I think I will do a quick video about tubes. I acquired some tubes in last few weeks, so I think I'll be sharing a few of them in this video today. Some of you might be waiting for my 300B project. Sorry to say, I need to delay the project a bit because it's a pretty heavy project, like 25 kilograms of transformers, 50 pounds roughly, with all the chassis and everything. It really requires a lot of work on the construction, right? So pretty busy with the job, with the work, so I need to delay those big projects a bit. But for sure I will be finishing those projects someday, but probably not in next 1 or 2 weeks. So maybe this time I just want to show some of my new acquired tubes. And the interesting one, I think the other is not so fancy, right? You know, this Toshiba, I bought it from Japan, mainly from Japan I bought it, 12AX7, and I think this one is a AU7, this is a high S, and I think this one is a hi-fi. It's a bit different because they say the hi-fi is more for audio, high S for instrument, which is more tighter in the tolerance. But anyway, this is definitely the high quality tubes that you can't miss it, right? This is another 12BH7A, and I think I got some other like a Toshiba 5814 and some other AU7. I think I got some NEC as well. Yeah, but I think that's probably not the thing I would like to show today. The interesting one is this CV4034. I think this should be Mullard tube 12AU7 compatible, and this is probably quite interesting tube because the construction is what we call as a flying lids. It will take some effort to open it, so this is gonna be like this. It's a CV4034. This should be Mullard long kind of plate construction, and this has flying lids. The ideal is you should be solder this directly to the PCB, but that probably won't be feasible for us to use this tube, especially when you want to do some comparison between different 12AU7. That probably won't be a good idea, right? It's a Brimar BVA England. You can see this very nice tube. I bought it locally from the local seller. This should be quite good tubes, not too cheap and also not too expensive, but I think it should be okay. So the idea is we need to solder this tube into something, and I bought this long time back from online. The idea is you can grab one, it has the base underneath the pins like this, and you just simply solder the lids from these tubes into this PCB, and likely after that you will be able to use this tube as per other normal tubes. You can easily exchange because it has pin underneath this PCB. That's the idea. I think today we're going to be doing some soldering activity for these Brimar tubes from the flying lids into the normal tubes, in terms of you can plug and unplug easily on any common 9-pin socket. So that's the plan for today. Let's continue. Okay, first thing first, I think we need to turn on my trusty GBC soldering iron. It's definitely one of the best soldering iron in the industry. One of the best, I would say. So yeah, this is my tools that I keep using for many times. And second, of course, what we need to do is we need to remove the base of the tube. So let me zoom the camera a bit. Hope you can see this one better now. Okay. So yeah, let's do the work for this tube. Okay, what we should do now is we should straighten up the pins a bit carefully. This is not easy because you need to do it very carefully to make sure that you are not breaking any of the pins. The pins is pretty delicate to handle. Will not be, and you need to be careful, that's for sure, right? This is not an easy work, not too difficult, but still, yeah, you need to be very careful. Very slowly, very delicate. Done. Here is the tube without the base. Good. This is the base basically, right? So what we should do next is we should put this tube into this PCB. But prior of doing that, I want to add a bit of heat shrink. Right? The idea is I want to give some space between the pins, and for the safety reason, I want to prevent the pins of being touched with the bare hands. So let's cut the heat shrink. Two, three, 4, 5, 6, 7, 8, 9, and spare 1 for reference for the second tubes. So see, this is what you will be seeing for the tubes. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. So long story short, let's try to put all this string into each of the pins. 1, 2, 3, 4, 5, 6, 7, 8, and finally 10 and 9. Sorry. So we have a good 9 pins bead string, lead string, and next is let's do some activity to heat up this. Just a bit, not too much. You know, we can see like this, perfectly shrink. At least from my perspective, it's perfectly shrink. you can say that again, but should be good now. Have a tubes like this and ready to be soldered to the PCB. Okay, and then let's find this socket. Should be pretty straightforward, right? 9 pins. You simply need to insert the tubes into the correct pin. Not too difficult, again, I would say, but not too easy as well, because you need to match the pins one by one. A bit meticulous work, but I guess it should not be that complicated, I think. Voila. See? Now the tube has been inserted correctly to the PCB. Just give it a little push here to make sure it fits nicely into the PCB. Okay. So you want to just adjust the pins a bit. And do some work. We need to cut the excess slits from here and do the final soldering work. Something like this. Not bad, huh? Not bad. Okay, so let's continue. Okay, finally let's do the necessary cutting. Need to cut this excess slit one by one. Okay. Two, 3, 4, 5, 6, 7, 8, finally 9. Have a clean underneath PCB lids. Okay. Okay. Now we have this PCB ready. We need to start soldering it. Okay. But I have a tips for you. When you solder these things, there's a chance the pin will move. The long pin will move, because when you melt the solder here, you also melt the solder on the pin side, right? And then it will make some problem, because if the construction of the pin slightly bent or slightly not straight, you cannot plug it easily on your tube socket. The tips is you need to use existing tube socket. I'm using from this tube socket that I use for my tube tester. Okay, so I will plug this here, plug this tube here, and then I will start soldering it with this condition. I know it's a bit difficult to solder this way, but it will make sure the pin will not move when you solder it completely. Because sometimes I used to do some excess soldering a bit to make sure it will go and melt the lids correctly, completely, right? Because it's a through hole PCB here. I want to make sure the tin will melt into the inside of the PCB as well, the other side of the PCB as well. So sometimes I do a bit of extra soldering, and that can somehow move or wiggle the main pins, right? So that will make this pin not straight anymore, so you'll be having a difficult time to insert it to the tube socket. So by locking the pins with the existing tube socket, I'll make sure whatever soldering I do, the main pins will not change in structure, condition, or whatever, or the construction, right? So that's the thing I do to make the things better. Yeah. So let's do it. I will put this on my jig, and we can do the soldering process. Okay, here is the position. I will put some of the Cardass rosin here. So let's see. I will put some rosin into the socket, into the lids. This will help to give a better, easier soldering. And then let's see, my GBC is ready. My GBC is ready, I guess. So let's do it. The tin is of course WBT, so this is gonna be a bit tricky soldering. I hope you can see it from that side. Okay, so let's do it. Okay, done one. Okay, third one here. Let's see. Continue. Okay, I think we can remove this first. See how the joints solder. So we're pretty okay, right? So pretty okay. Yeah, it's also being absorbed to the other side. It's pretty good. So let's do for the last three. Come on, 3 more to go. It'll be tricky here. It's done. This one should be okay. The last one you can do from this angle, right? I hope your camera still can capture it. Okay, that should be a good quick soldering process. Let's see. I guess not too bad. Not too bad. Okay, let's do some touch-up, clean-up with the isopropyl alcohol and see the final outlook of these tubes. And finally, we will do some cleaning with the isopropyl alcohol. Okay, so it should be okay. Let's open this IPA and get some IPA bit here on my tweezer, and then let's do some quick cleanup on this. This should be good enough to clean all the excess flux and all the dirt and everything from the PCB. I like to get my finish, my soldering quality finish is good. I like to make it perfect. I don't like excess kind of a flux which showing some yellow coloration, right? So you will have kind of cleaned PCB like this and make it closer, right? No excess flux, no yellow color. It will be nice, clean, shiny soldering with WBT thin solder. So this is something that I like, right, on my product, on my work result. So I guess this is more or less it, guys. I'll do a bit of extra cleaning again here to make sure things are clean and tidy, so I will show you the final result later. But so far I think it's quite good. Okay, finally this is the final construction of this tube, Brimar CV4034. Should be 12 AU7 tubes. If you can see here, it is quite neat, I will say. Not bad. I add some thin solder joint between the leads and the pins here, if you can see it. Hope you can see it. Let me try to reduce the ISO a bit. See, I add extra solder here between the leads and the pins. The idea is I want to have a good connection between the leads and the pin directly, right? You can see the same elsewhere. We are doing this, so just to make sure that we have a good connection. I don't want to rely on the PCB lines here, so I want to make sure the connection is good between the leads and the pins, right? So I solder join directly between both of them. If you can see here, this is how I do the work. Just want to make sure it's perfectly connected between the leads and the pins with the solder, with the WBT. I believe you know this brand. 4% silver solder should be my reference for most of the application. And if you can see here as well, we also add a good solder here to make sure that it's a true hole PCB, so both sides are being connected perfectly, right? So the same across the others. We are doing the similar assurance that the solder joint will be perfectly there, right, in the both side of the PCB. So yeah, this is basically it. Maybe I have a bit disappointed that, if you can see here, maybe not so clear, but the tube is slightly not straight, right? It's slightly towards the left side a bit, right? Yeah, I'm a bit OCD person, so I kind of able to see, if you see this way, the tube is not totally center, it's not totally straight, slightly bent to one side. But anyway, that's the imperfection that hard to achieve, right? Especially because the leads sometimes they are not in the same length when you push it here and there, right? And yeah, basically that's it. So again, that's all for today, guys. So thanks for watching and see you again next time. Take care. Bye bye.